Hello everyone, I'm Anupama, and today what we are doing is, as electric charges and fields, it's already done. So we have done half of it, so we are going to complete it today. So last time what we discussed, like what is electricity, and then electrostatics, current electricity, and then electrification, electric charge. So basically I will give you a simple overview. So first one is, it is a branch of physics. As what is electricity? It's a branch of physics which deals with the study of electric charges, right? So afterwards we have two types. So what are those two types? So one is electrostatics, another one is static, same thing, static electricity, and then we have current electricity, right? So static electricity is basically when electric charges are at rest, means basically they are not moving in here and there. So basically if a charge doesn't move here and there and it stays as it is, so that one is electrostatics. Okay, that branch of physics like which deals with that type of charges. And then we have current electricity, as basically it's the electric charges at motion, means basically those are moving here and there, means displacement is happening. And then we have electrification, means making the body lose or gain electrons, like basically all the actions you see, right? So whether the body is taking, what is the body? Basically conductor, like the one who takes and the one who lets the charges move into it is a conductor, right? So that one is a process of making a body lose or gain electrons. Okay, so body means it doesn't always have to be a conductor, like basically lose and then gain. Basically if it enters through it, then only it is a conductor. So let's just use as a body only, like it is a process of making the body, like body. Okay, so as you can see here, and then we have properties of electric charges, as one is charges conserved, and then we have charges quantized, and then we have charges additive. So first definition you see here, as I will pause for a while, and then we have electrostatics, you can screenshot it, and then we have electrification, and then we have what is electric charge. Charge is basically a property of matter, like by virtue of which it repels its own kind and attracts the opposite kind. So then we have like charges, as like charges repel each other, unlike charges attract each other, as I already told you. And then we have methods of charging a body, as first one is charging by friction. So what is friction? Basically like by moving, as I have already written here. So by moving. Charging by conduction means basically charged body plus uncharged body, like when they rub together, like then we see the charge is produced. And then we have charging by induction. What is induction? Basically charged body near uncharged body, like this one we rub together, like basically we make the contact of charged body and uncharged body, then it gets conducted, like the charge get passed on. But in here in induction, just the charged body is moved near the uncharged body. Okay, then we have Coulomb. So it's really important, like basically they will ask you the question based on this. So what is Coulomb's law? So basically I will tell you, I will read once. The force between the two charges, I already done that, but still, the force between the two charges is directly proportional to the product of magnitude of charges and inversely proportional to the square of distance between them. So you will be like, what is magnitude? So basically you have a question when you are reading this one. So first one is one, it is the one, okay, one is positive, one is negative, but we should consider positive. So what do you mean by that? One is, what do you mean by one? Here I am talking about charge. So one charge should be, it would be positive, one charge it would be a negative. So as you know that unlike charges attract each other, right? But for now we have to consider the negative one also to be positive, because we are talking about, like we are calculating the distance between them, and also like how the force gonna act between those two charges. So basically we are talking in terms of that. So that's why we need to consider that these two are positive charges, although like as the basic principle we know, unlike charges like attract each other, but for now let's consider that's positive. Okay, so why we need to do that? As I already told you, to see like the to apply this Coulomb's law. Okay, then we have these two charges, as you can see, Q1, Q2, and then we have, okay, R. As you can see, distance between these two charges is R. So how you can write this like statement? Simple way. So look at this formula. This is a really important formula, as you can see. So I will show you. F. So basically what you see here, force. This is a force of attraction or repulsion. 1 by 4 pi epsilon naught Q1 Q2 R square. So why are we doing R square? What is R here? R is distance. So basically what is Q1 Q2? These are charges, right? And then we have epsilon naught. So what is epsilon naught? You're gonna know here, as I will tell you. So epsilon naught is basically permittivity in free space, means in vacuum. So permittivity you guys already know in your first PU. If you don't think too much about it, because they will not literally ask. You just have to mention its permittivity. That's it. As I will tell you, this is magnitude. So see the definition. The force between the two charges. The force between the two charges is directly proportional. Okay, so not directly proportional. Okay, directly proportional to the, see, directly means what? Basically we are talking of here, like the numerator. Okay, force between the two charges is directly proportional to Q1 Q2 by R. We cannot say by. So inversely proportional means what? Basically I will show you. Inverse means basically 1 by. Okay, if we are talking about directly, means basically we are talking here and here. That's it. So whenever you think what is inversely, what is directly, so basically we are talking here is inversely means we are basically talking like this, like 1 by, means here it is 1 by R square. Okay, so now let's do that again. Force between the two charges is directly proportional to what? Product of magnitude of charges. So product of magnitude, you need to remember, product of magnitude of charges, and inversely proportional to square of distance between them. So sorry. So after that, what we have, let Q1 Q2 be the charges of magnitude of charges. Same thing, you need to write the same definition, like basically like you are explaining like what are those charges. Basically those are the product of like magnitude of two charges. Okay, so Q is magnitude, basically 1 and 2. This is a position, oh sorry, not magnitude, sorry. Q is what? Basically it's a charge. So Q1 Q2, and then we have this one. This is the formula. You need to definitely write it in your exam and explain like what is F. F is the force between the two charges, and then after that what we have, Q1 Q2, what is it, and then R. You need to write that one. Okay, as then what we have it. So what is epsilon naught? Epsilon naught is basically absolute permittivity of free space. So what is absolute permittivity? So you will get to know, because you have already learned it. So don't think too much. I'm not dragging, because if you need it I will tell you. If you don't need it, I will just skip that part and move to the most important ones. So then we have define Coulomb. This will be asked in your like unit test or something, like in your midterms or something. And maybe now it's your finals exam nearing, I know. So you can use these videos as an revision and also to know what is important. So 1 coulomb of charge when placed in a distance of 1 meter. What do you mean by that? Like coulomb, 1 coulomb of charge means what? Basically here you can see 1 coulomb means it is a charge value. Okay, 1 coulomb of charge in a placed at a distance of 1 meter means, let's say this is 1 coulomb of charge. Okay, it's placed in a distance of 1 meter with the another charge. Okay, of the same magnitude in vacuum, means these both are having same magnitude. Okay, what is magnitude? Basically same level of charge, you can say. And then experiences an electrical force of repulsion of magnitude. So I told you one thing. What was that? Basically, even if this charge is negative, you need to consider it as a positive one. Why? Because we need to see the force. If we consider it as a negative, what will happen? Basically, like if we consider that as a negative, the both charges will just merge together and we can't get the force. Like, what is the force acting between them? So basically, so I consider it as a positive only, right? So it experiences force of repulsion. Why? You guys already know, like charges repel each other. So that one, force of repulsion of what? Like how much? So force of repulsion of magnitude 9 into 10 point, 9 into 10 to the power of 9 Newton. So they experiences like force of repulsion of this much. Okay, so you need to remember this definition. Don't cram it, just understand it. Like that one is our motto. So one coulomb of charge is placed in a distance of 1 meter. I will write it down. Like let's say these two are charges, okay? And then what we are doing, Q1 and Q2. So let's say this is a 1 coulomb charge and this is 1 coulomb charge, okay? So these are placed in a distance of 1 meter, okay? This is R basically. So what we are seeing is they are having the same magnitude, okay? And then in vacuum experiences an electrical force of repulsion. Basically they experiences force of repulsion as of the magnitude. So what is the magnitude? So basically it is 10 to the power of 9 Newton, okay? That's it. And this one, this value they will ask you in your MCQs. Yes, they will just give you this epsilon naught and they will ask you, okay, so what is the value of it? They will just see, they will not play with this number 8.8, okay, 8.854 into 10 to the power of minus 10 to the power of minus 12 they will give, 10 to the power of minus 18 they will give, so that you can get confused, but don't get confused. And here you see how this came. Can you tell me like how this particular SI unit came? So basically you need to see here and then here. Just try to make sense how this is gonna be. So, and they will also give you SI unit as well. SI unit is also asked. So you need to see this one, okay? And then we have this one. So magnitude, I was speaking of magnitude, right? So this is in this definition, as you can see. So the definitions are basically in this. This is the magnitude, this is the charge, this is a distance. That's it. Just know. Superposition, they will not ask you that much, but you have to know the final one. So here, as you can see, so this one you need to know, okay? Or Q1 by 4 pi epsilon naught, and then here you need to know this particular formula. That's it. They will not ask you. And then here you have, if we place a known medium. Okay, what do you mean by that? If we place a charge in a known medium, if we place a charge in known medium, like basically it will, these are all this, I will show you neatly. All this you can see, these will be there in your KCET. Yes, KCET, if you are preparing, just know this really nicely, because this will help you during that time. So in a known medium, if it is there, so basically at that time you need to use this formula. If it is an unknown medium, you need to use this formula. So in a known medium, and then in the, if it is unknown medium, and then F0 and Fm, so this one is also there. You will know in your KCET. If you have time, see it in your board exam. Just know, write this down, and then you can ask your teacher about it. For now, we are just revising what is important for our board exams, okay? So we have the least possible value of charge. E is equal to plus or minus. So plus or minus, why did we use that? So basically, like, possible charge can be plus or minus, right? Like either it could be plus, either it could be minus, right? So that's why 1.6 into 10 to the power of minus 19 C, matlab coulomb, okay? So this one is the value of charge, means like E. So the value of E is this one. They will ask you in your exams, and this value you will generally know this one still. And then we have Q is equal to Ne. What is Ne? Basically, Q is equal to number of electrons. number of electrons constitute in 1 coulomb of charge. So basically, as I will show you. So here what you see, we have Q is equal to Ne. This is the basic general formula. And then we have the number of electrons constitute 1 coulomb of charge. Means basically when we are talking about 1 coulomb of charge, so what are the number of electrons we have? So basically 1. Okay, here only I will tell you. Q value is 1. Why? Because like Q's SI unit means basically electric charge SI unit is what? Coulomb, right? So 1 coulomb of charge is there. So we put the value of 1. And then we have electron. Electron value I already told you, right? So this one is E, as I was saying E, this one is electron. So this one's value I already put in here. So we have the 6.25 into 10 to the power of 18 electron. Okay. So this one is the value of number of electrons present in 1 coulomb of charge. If they ask you, this is the answer. 6.25 into 10 to the power of 18 you need to write down. Okay. And then the number of electrons constitute in 1. Okay, this one, let's say. If you know, let's answer me, okay? So 1 milli of charge is N is equal to 6.25 into 10 to the power of 12 electrons. So this one you need to know, okay? Electric field. So basically what is electric field? It is a region in which the charged particle experiences some force. What do you mean by that? Like basically there is a region, okay? Let's say this is a particular region, let's say, okay? So in this region if we place a charged particle, so which one will be charged particle? Let's say if this is a charged particle, okay? So it experiences some of the electrostatic force. Means basically what is electrostatic force? Basically it's the charge experienced by an body, like without any displacement, right? I already told you, if there is no displacement, basically it's electrostatic force, right? So when a body is placed in a region where they consist of some charge, so it experiences some of the force. So that force is basically the electric field, okay? And listen to me, electric charge is scalar quantity, this electric field is vector quantity. Don't get confused in that. And then your teachers also have told you, but now I just remind you, okay? And then what is electric field strength? So electric field strength is basically, I will in simple way, I have written this one. Electric field strength is a force experienced by a unit positive charge in an electric field at a point. So what do you mean by that? Like it's a force experienced by a unit positive charge. Means unit is what? Basically 1. Like basically a single positive charge is being placed in a electric field, means at a point, like in some point it's placed. So the force which is being experienced by that, so that one is electric field strength. Understood? So again I will show you in a visual way. So if I place a charge here and the force experienced by a unit, this is a positive charge, unit positive charge is this one, okay? So experienced by that in an electric field, this is an electric field, right? So experienced by that is called electric field strength, okay? The how much force it experiences. And then we have the formula. So what is that? So E is equal to F by Q naught. So what is F? Here it is force. Q naught is what? Basically like it's a test charge, okay? Means basically we have placed a unit positive charge, right? To test what? To test the strength of the electric field. I mean electric field, oh sorry, not test. I mean how much electric field that particular body experiences. So that one. So it is a test charge, what we call. So if it is a knot in here, like below Q, if there is a knot, that one means it is a test charge, okay? And then we have SI unit of electric field. So what it is? Okay, this one electric field. See force, SI unit is what? Newton. Q naught, so what? Basically it's a charge. So charge SI unit is what? Basically it is coulomb. So when something is below, I mean as you can see, this one is Newton, this one is coulomb. So when we are talking about inverse here, if it goes up, its charge basically it gets a -1. So if it have a square here, it will become -2. Okay, you need to know this basic thing. Okay, when you are in exam, you need to write the SI unit also. If you get confused at the time, do this. Okay. Then we have electric field expressions. So what is electric field expression? These things don't see, look here. So this one is all important. This one you need to know, as this is for your KCET. I know you will not understand anything right now, but just write down when you complete your PUC. At that time you'll be like, oh, this does make sense. I mean, so E is equal to 1 by 4 pi epsilon naught Q by R square. So why did I use that? This is magnitude, okay. This one is charge. So basically Q, okay, R square is what? Basically how this particular expression came. This will be shown as in the same like expression. I will show you the expression. So at that time I will explain, okay. So basically, as you can see here, these things you don't need to know. Superposition of electric field, you don't have to mug up all the this, how this came and everything. When you are practicing for your final exams, at that time you need to know, okay. At that time you need to just blurt it out. What is meant by blurt? Basically you learn and then you write down without looking at it. This is really easy, you can just mug it up, okay. So it doesn't come in your exams, so that's why just know it, okay. What is electric dipole? So it is a pair of two equivalent opposite charges separated by a small distance. You can mug it up. Even when I was in your I was in second PUC, I just learned it. So how? Basically these two have equal strengths. Basically these are of opposite charges and they are separated by a small distance, okay. That's it. And then you will ask me, okay, two equal and opposite charges separated by a small distance, so why don't they like combine? Why they don't do that? Because they are separated in a particular like small distance, means basically their contact is not that near, okay. If there is near, even you see magnets, like basically do they just if a place like this, do they just come and, okay, if the distance is low they join together. If the distance is small only but still a little bit far, so that they don't experience the forces, at that time they just don't join. So then electric dipole moment, it is a product of magnitude of either charge of the dipole and distance between the two charges of a dipole. So don't think too much. Here you have the formula, right? So what is electric dipole moment? Electric dipole moment is basically product of magnitude of either charge, means either this one or this one, either charge of the dipole and distance between the two charges of the dipole, means here the distance is there, right? So distance between the two charges of a dipole. So basically we take the magnitude of either one charge which is present in the dipole, and then we take the distance between the two charges of the dipole, okay. So that one. And then we have the expressions which I will explain in the next video, as it will be uploaded sooner. So only this much we have. So these are some of the theory, expressions which are really important. This will be asked in your exams in 3-4 marks or 5-6, oh say not 5-6, 3-4 marks or 5 marks maximum. So these are some of the formula list, so which I will upload it in your community post. I will do it. So that much for